Okay, this is 3.3. It is about using ratio tables. So 3.1, we learned about what ratios are and equivalent ratios. In 3.2, we learned one way to solve ratio problems was using a tape diagram, and today we are going to use another tool called a ratio table. I think a lot of you are going to prefer ratio tables to tape diagrams, but there are uses for both, so that's why we learned both. Could I have a volunteer read the learning target for us where it says LT, please? Natalie? Thank you. So you can find and organize equivalent ratios in a ratio table. You can generate a ratio table by using repeated addition or multiplication. I want us to kind of cross off this repeated addition idea because really, truly, what we want to be using most of the time is multiplication and division. So I want you to we're going to edit this a little bit. It is true that you can use repeated addition. It is true that you can use repeated subtraction. But a surefire way to always know how to complete a ratio table is to use either multiplication or division. So that's what we're going to focus on today. So, quick reminder, if I had the ratio 1 to 2, can anybody give me a ratio that would be equivalent to that? Kaden?
2 to 4.
2 to 4. What's another one that would be equivalent to that? Farhan?
3 to 9.
3 to 9 would not be equivalent to that ratio.
Why? I thought you were doing this.
No, well, the next one, if we wanted to do 3, right? If we have 1 to 2, 2 to 4, if we want to do 3, it wouldn't be to 9, it would be to, Natalie? 6, because as this one goes up by 1, this one's going up by 2. After 3 to 6, what would be our next equivalent ratio? Logan?
4 to 8.
4 to 8, what would be after that, Swara? Yep. What if I wanted the first number to be 50? Does anybody know what the second number would be? If my ratio is 1 to 2, but I want it to be 50 to something, what is that something, Maya?
100.
Exactly. Whatever you're doing to one number, you're doing to the other. So 1 times 50 makes 50, 2 times 50 makes 100. That's what we're doing today with ratio tables. So we're going to fill it in, and then at the end, we're going to write the equivalent ratios. So this has triangles to sides. So when I have one triangle, there are 3 sides. The next column shows that now I have 2 triangles. How many sides would correspond to that? Mia?
6.
Here's how we can know that if we're not really sure what number goes there. What do I multiply 1 by to make 2? 1 times what makes 2? Emma?
2.
And if I repeat the same process on the bottom, 3 times 2 makes 6. Now in the next column, I have not the number of triangles, but the number of sides. I know there are 9 sides. Does anybody know how many triangles are going to correspond to 9 sides? How many triangles should go above that? Farhan?
3.
Now we can figure that out because we know that every triangle has 3 sides, okay? But let's say we again want to use our multiplication idea. Is it easy to multiply 6 and turn it into 9? I wouldn't say it's easy. We'd have to multiply it by like a fraction or a decimal. But is it easier to multiply 3 by something and turn it into 9? What do you guys think?
Yeah.
Yeah, I think that's a little easier. What do I multiply it by? 3 times what makes 9? 3 times what makes 9? Dash?
3.
That means if I use the other value in that ratio, so above the 3, that would be a 1, and I do the same thing to it. 1 times 3 makes 3. So this is kind of like in 3.1 when you had to fill in like what value would make these ratios equivalent. That's what we're doing here. Our last one has 4 triangles. How many sides should go underneath the 4 triangles? Swara? We might know that because we know each of the triangles has 3 sides, but remember we could also use multiplication. Which number would you like to start at for the triangles? Which would maybe be a good starting place to go to 4? A number that we could easily multiply and get to 4. Kaden?
2.
Sure. Some other people might use the 1, but either of those. Using the 3 might be trickier, but using the 1 or 2 would probably work pretty well. What do I multiply 2 by to make 4? 2 times what makes 4? I want to hear from someone I haven't heard from yet today because I know you know the answer to that question. 2 times what number equals 4? Tanner?
4.
2 times 4 would be 8. I want 2 times what equals 4?
2 times 2.
There you go. That means if I started at the 2 on the top, I need to start at the number on the bottom that is underneath the 2. So at the 6. So 6 times 2, that's how we get 12. So we can see here, this one was kind of repeated addition. They were adding 1 on the top each time and adding 3 on the bottom each time. But there are certain instances where it's not as simple as that. So that's why I want to show you this multiplication idea so that when we get to one where that's like the easiest thing to use, you know how to do it. There was a second part of this question. It did not just say to find the missing values in each ratio table. What else did it ask us to do in the original directions? There was another piece. What else did it ask us to do? Tanner?
The equivalent ratio.
Yeah, and I haven't done that, so I need to do that part. Does anybody think they can tell me the first ratio in this table? Or actually, let's start with how many ratios are in this table? How many ratios are in that table right there? Aubrey? There are 4. Who can tell me the first one? Ratisha? 1 to 3. What's the next one? Dash?
2 to 6.
What's the next one? Kaden?
3 to 12.
Not 3 to 12.
Oh,
3 to... What's underneath the 3? Farhan? 3 to 9. And what's the last one? Neil?
4 to 12.
So we can't forget that at the end we need to write the equivalent ratios. All the ratios in this table are the top number compared to the bottom number. So some students will try and do like 1 to 2, 3 to 4, 3 to 6, 9 to 12, but the ratios are top to bottom because we can see that the top number is the triangles and the bottom number is the sides. So each ratio should have a number from each. Triangles, sides, triangles, sides, triangles, sides. Questions about example 1A? Okay. We're going to move on to the next one. This one is frogs versus toads. So the ratio of frogs to toads is 4 to 6. But this time I have 20 frogs. What can I do to the 4 frogs to turn it into 20? What would I want to multiply it by? Multiply it by Phoebe?
5.
That means then I do the same thing to the bottom. And what do I get as the number of toads that should go there? Ratisha? What'd you say? Because 6 times 5 is 30. All right. Now, the next one, I don't know the number of frogs, but I know the number of toads is 90. Actually, going from 30 to 90, that's not too difficult to do. Last time, the numbers next door to each other were kind of difficult to get from one to the other, but in this case, it works a little easier. What do I multiply 30 by to make 90? 30 times what makes 90? Emma?
3.
Because I started at the 30 on the bottom, what number should I start at on the top? Which number am I going to take and multiply by 3? Logan? The one right above it, the 20. So 20 times 3, I get 60 frogs. And now I have one more to fill in. Oh my gosh, again, it's not that tricky to go from the neighbor to the next one. So we're going to just do that. What do I multiply 90 by to make 180? 90 times what makes 180? Lisandro?
2.
So which number should I start at and multiply by 2 on the top? Which number am I going to do that to? Maya?
60.
The one above where I started on the bottom. So 60 times 2, 120. Before we do the equivalent ratios, questions about how I filled in any of the values on this table? Okay. What's the first ratio in this table? I would love to hear from someone I haven't heard from yet today because this part you're just telling me a ratio. What's the very first ratio in this table? Graham? What'd you say? You're looking at this one. We're on this one, the frogs and toads. Yeah. What's the next one? Shelby? And the next one, Hudson? And the last one in this table. Farhan? And we're done. Questions about example 1A or B? Okay. We're going to move on and we're going to do a couple more examples. Similar idea though. So this table has the number of dollars compared to the number of cents, 1 to 100. So next I need to go from 100 to 300. What do I multiply by to make that happen? 1 times what makes 300? Logan? 100 times 3. So I do the same thing to the top. 1 times 3, that's 3. Okay, next I need to get to 900. Should we start at the 100? Should we start at the 300? Does it not matter? Shelby? Yeah, because we can start wherever we want, and both of them work pretty nicely. I'm going to start at 300. What do I multiply 300 by to make 900? Svara? And then I do the same thing to the top. 3 times 3 makes 9. Now on the top, I have an 8. Which number should I maybe start at to try and get to this 8 that's on the top? What would be my best starting point of the top numbers? Mia? Yeah, because going from 3 to 8 or 9 to 8 would be using some sort of fraction or decimal, but going from 1 to 8, I don't have to use a fraction or a decimal. What do I multiply 1 by to make 8? Emma? 8. So, does that mean now on the bottom, I'm going to do 900 times 8, and then I will know what's next door? I'm seeing some yes, I'm seeing some no. Who can tell me what should I start out on the bottom? Which number should I be multiplying by 8 from the bottom? Ratisha? What one? How did you know I should use 100 and not 900? It's not necessarily because it'd be too big, but how do I know that I need to start at this one? It's at the same spot, yeah. Because if I started at the 1 on the top, I need to start at whatever is underneath that on the bottom. That's the most common mistake students make, is they find a way to get from one number on the top to another number, but they don't start at the same place on the bottom. Because I started at 1 on the top to go over here, I needed to start it at 100 on the bottom to go all the way over there. You also could have done something going top to bottom here. Does anybody see what is happening to each of the top numbers to reach the bottom numbers? Maya? Yep. That would have been another way we could have done it. What's happening from the bottom to the top? Aubrey? Yep, because remember we said you could also use division. So you could have filled this out in one of 3 ways. You could have done the way that we talked about. You could have just done each number on the top times 100 to get the one on the bottom, and each number on the bottom divided by 100 to get the one on the top. Now we're going to write our 4 equivalent ratios. Those are 1 to 100, 3 to 300, 9 to 900, and 8 to 800. Questions about 2A? All right, 2B. Meters to minutes. 3 meters, 1 minute. Now I have 2 minutes. How do I go from 1 to 2? What would I need to multiply by? Natalie? So then 3 times 2 makes 6 for the top. How could I get from 6 to 2 on the top? Aaron? What'd you say? Divided by 3, so we have to use division this time. So then what number should I be dividing by 3 on the bottom? Should I be doing 1 divided by 3 or should I be doing 2 divided by 3? Farhan? But the 1 is underneath this. I started here. So I should be doing 2 divided by 3. Wherever you start on the top is where you need to start on the bottom. What's kind of tricky about that? Dash? So I'm just going to write it as a fraction because it's just going to be a fraction because we can't divide it without making it a decimal or just writing it as a fraction. All right, and last but not least, I need to get to 5/3. What seems like the easiest way to get to the 5/3? Which number would maybe be our best one to start with? Aubrey? We could. I actually think that's kind of tricky though, trickier than, because trying to get 2 to 5 isn't that easy. I see one that might be better to start with. Ratisha? 1 is always an easy one to start with because you just need to multiply it by that thing times 5/3. So then what number should I be starting at on the top? If I started at the 1 on the bottom, which number should I start at on the top? Logan? The one above it. So 3 times 5/3, which is 5. All right, now just like last time, we're going to real quick see, could I have gone from top to bottom or bottom to top in a particular way? What was happening from the bottom up to the top each time? What were they doing each time? Mia? Well, 1 times 2 doesn't make 3. 2 times 2 doesn't make 6. That's okay. What were we multiplying by each time? 1 to 3, 2 to 6, 2/3 to 2, 5/3 to 5. What was getting multiplied by each number on the bottom? What were we multiplying it by to go up to the top? Hudson? 1 times 3 is 3. 2 times 3 is 6. 2/3 times 3 is 2. 5/3 times 3 is 5. That means if we wanted to go from top to bottom, what was happening? Bottom to top, we were multiplying by 3. What was happening if we go the other way, top to bottom? Natalie? The opposite thing, divided by 3. Because 3 divided by 3 is 1. 6 divided by 3 is 2. 2 divided by 3 is 2/3. 5 divided by 3 is 5/3. Questions about how I filled in the ratio table? Ratisha? Huh? 5/3 times 3, which is 3/1. Cross cancel. You get 5. 5 is simplest one. Other questions? Okay, now we're going to write those 4 equivalent ratios, and then we have one more problem. So 3 to 1 is our first one. 6 to 2 is the second. 2 to 2/3 is the third. And 5 to 5/3 is the last one. So far we have learned that in a ratio table, you need to either be multiplying or dividing each number by the same amount to get to one of the other ratios. Or you can multiply every number from like bottom to top or top to bottom. That is also an appropriate strategy. So our last one is a word problem. So this is where we really want to see how are these actually helpful, because in life, you're not ever going to really be given a ratio table and they're going to say, fill this out. But there might be problems where creating a ratio table could help. So this says a nutrition label shows that there are 75 milligrams of sodium in every 12 crackers. You eat 30 crackers. How much sodium do you consume? So what they're trying to get us to do here is to create an equivalent ratio, a ratio that is equivalent to 75 milligrams of sodium to 12 crackers. but they want the number of crackers to be 30. So I'm going to set up a ratio table that shows this. So I'm going to put sodium on the top, and I'm going to put crackers on the bottom. It doesn't really matter which one is on the bottom and top. I'm just doing it that way because that's the order I was given it in, but if you did it the other way around, it's fine. What ratio can I start by putting in my table? What is a ratio of sodium to crackers that I know from the problem, where I was given both values, so I know the ratio of sodium to crackers is this amount. Mia? So I know when there are 75 milligrams of sodium, there are 12 crackers. Okay, cool. I got one ratio in my table. I'm only given one other number. That's because they're only giving me one number of the ratio I want, and my job is to find the other one. What is the one other value that I was given? Aubrey? So I'm going to put 30 crackers on the bottom, and I'm actually going to leave an empty space in the middle. And that's because trying to go straight from 12 to 30 is not particularly easy, right? If I count by 12s, I get to 24 or 36. So we could multiply it by a fraction or decimal, but to avoid that, I'm going to give myself room in the middle to do kind of a step in the middle that might help me. So my goal is to find what number goes right there, how much sodium is in these 30 crackers. Okay, so first, I am going to try and get the number of crackers, 12, to turn into something that is a little easier for me to use to get to 30. What could I maybe divide or multiply 12 by to make it something that's a little nicer for us to use if we're trying to get to 30? Shelby? Yeah, that would work because 6 to 30 is much easier. 6 times 5 makes 30. That means now I know the steps that I need to be doing across the top to find my missing amount of sodium. So 75 divided by 2. That's what I need to do first. Two fits into 7 3 times, which is 6. And then when I subtract, I get 1, and I brought down the 5. 2 fits into 15 7 times, which is 14. And then I got a remainder, so I'm going to put a decimal and a 0 so that I can divide one more time, because I will be able to fit 2 into 10 5 times. 0. So that means the next number, when there are 6 crackers, there are 37.5 milligrams of sodium. What is the last calculation I need to do here to find the final amount of sodium, the amount that is in the 30 crackers? Logan?
37.5 times 5.
Yep, because we decided that we're multiplying by 5 on the bottom, so I'm going to do the same to the top. So 37.5 times 5. 5 times 5 is 25. 7 times 5 is 35 plus 2 is 37. 3 times 5 is 15 plus 3 is 18. 187.5. So that is the amount of sodium in 30 crackers, because the whole goal here was to create an equivalent ratio, a ratio equivalent to 75 milligrams of sodium in 12 crackers, but where there are actually 30 crackers, and we can use a table to do that.